Welcome back to Dragon Dreams. Ivan here. Have you ever wondered how D&D dice probability works? Ever been hard to figure out your chances of doing something in the game? Ever homebrewed something and been unsure what dice would be good to throw? Today I thought I'd break down how dice actually work to demystify all of that. Stay tuned. Let's start with a simple D10. That's really easy. You have a 10% chance of rolling any given number. It's a 10% chance to roll a 1, to roll a 10, to roll a 6. You get the idea. So I started out with this because it may seem absurdly easy, but it makes the math easy. As we start going to more and more D10s, it makes it really easy to calculate the math. Okay, and then we can go to other dice that aren't base 10 and we'll understand them better. So let's do 2d10. Now that's a bell curve, right? Well, technically we might call it more like a wedge curve because it's not actually in the shape of a bell, but close enough. Let's take a look at all the possible results. So throughout this video, I'm going to use this really nice web application that I think you're really going to like called anydice.com. It not only rolls dice for you, but it shows the probabilities, both listing them out in a table format and graphing them so you can see the curve. All right, so let's take a look. As you can see here, there are 100 combinations. 10 by 10, right? Because you can roll the first die and get 10 different results, and you can roll the second die and get 10 different results. There's 10 combinations for each. In probability, when we look at percentages, we multiply, right? So there's 100 different combinations because you could get, the 1 and 1, 1 and 2, etc., all the way up to 10 and 10. So there's only one way to get a 2, which is 1 and 1. There's only one way to get a 20, 10 and 10. So each of these only has a 1% chance of occurring because both dice need to be rolled with the exact same results. And 10% times 10% is 1%. Okay, but let's take a look now at 11. There are 10 different ways to get that because it goes right along the main diagonal if you draw them out, on X and Y coordinates, right? So you get, you can have a 1 and a 9, a 1 and a 10, right? You can have a 2 and a 9, etc., right? And so there's like 10 different ways you can get an 11. So there's actually a 10% chance of getting an 11. And you can see here that there's a much higher chance of getting middle numbers than numbers on the end, smaller and larger numbers. That's why it's a curve. See? So what this means is that lower numbers and higher numbers in any given curve are going to be a lot rarer than middling numbers. And the more dice we have, the steeper the curve is going to get, as we'll see. But right now, the curve isn't super steep, so there's just, a 9% difference between the extremes and the most middle number. But let's take a look at the at the graph here, and you can see the angle curve. All right. And so here's the thing. For a while, there was sort of this trend in like indie games to do 2d10s instead of d20s. That was a thing for a while, but it doesn't work because now you can see that it's not really a very good idea. Let's say you need a nat 20 for something. On a d20, that's a 5% chance because every notch on a d20 is 5%. That's hard, but it's not impossible. Whereas on 2d10, in order to get a natural 20, you only have a 1% chance. That's almost not really worth doing, right? Let's say you needed a 19 or higher, right? So on a d20, that's 10%. But, that's hard, but it's still doable. But on 2d10, it's only a 3%, which is still almost not worth it. Let's say it's 18 or higher. On a d20, that's 15%. Not great odds, but it could definitely happen. But on a 2d20, it's only 6%, which is only slightly better than a nat 20 on a d20. You see the problem? All right, so now let's try 3d10. Now you might be wondering why I don't just show you 3d6. I mean, after all, that's what you use for ability scores, right? Well, we're going to get there, but remember I said d10s are easy. So 3d10 turns out to be pretty easy to think through, but 3d6 is kind of hard. So let's do 3d10s first. So here's a really nice example of the famous bell curve. So you can see here the graph on any dice, and this time it actually looks like a bell. It's this nice, bell, right? So notice that it's really getting unlikely to get really low numbers. Just 0.1% to get a 3, which is the lowest possible number you can get. And also a 0.1% to get a 30, which is the highest possible number you can get on 3d10. So that's because we're dividing by 1,000. Remember, it's 3 dice now, so the number of combinations is 1,000, 10 times 10 times 10. There's only one way you can get a 3, which is 3 ones, and only one way that you can get a 30, which is 3 tens. So your chances for each one of those is 1 in 1,000. All right? But 16 and 17 each have a 7.5% chance. That's because there's a lot more ways to get those. There's actually 75 different ways that you can get a 16 or a 17. 75 divided by 1,000 is 7.5%. Following me so far? So the point being that unlike with the 2d6 angle curve, where it's not quite so different, now we're getting into some pretty big differences. Like, it would be absurd to expect anybody in a game to roll a 3 or a 30 on a 3d10, right? Like, that's just not going to happen. But it's a 1 in 1,000 chance. Like, that's just almost like obscenely. It's either obscenely easy if you succeed with anything of a 4 or above, or obscenely hard if you have to roll a 30. Okay, now let's look at 4d10. Once again, here's the table. I don't think we need the graph this time because I think you get the concept of what a bell curve looks like. Now notice how crazy this is. To get a 4 or a 40, it's 0.01%. 1 in 10,000. Practically impossible. Why even roll? Whereas 22 has a 6.7% chance. Let's take a look at this in another way, using any dice's at most feature. So now this shows us what chance we have of getting a given number or less, at most that number, right? So notice how insane this is. So if you needed to roll a 12 or under, or let's say, you could succeed in a 13 or better, right? Same thing, right? Your chance of failure could be what we're looking at. You'd only have less than a 5% chance for that to happen, right? So now let's look at it another way with the at least feature. Same thing, but this time getting at least that number. So now if you needed to roll a 32 or higher, that's approximately 5%. Wow. So there's about a 90% chance that your rolls are going to be between 12 and 31. Remember that the actual range is 4 to 40. All right? So this is really important to know, because it means that as the number of dice goes up, the range of probable rolls closes. Okay? You don't want to have a game where you're likely to need a roll that you only have, say, a 1 in 1,000 chance of making. That would be a really ridiculous game. There's no point in rolling. So what chances are fair? I don't know what you think, but I would say that anything less than about 5% is kind of pushing it. Okay? Okay, so now let's go back to 3d6 that you roll your ability scores on, because now that we understand how d10s work, we can apply that knowledge to d6s and it will be clearer. Okay, so here's the table. As you can see, it's pretty interesting. If you roll 3d6s for ability scores like you did in old school D&D, where you just roll them down the line, you're likely to get scores that are fairly middling. Your scores might be between 9 and 12, and in old like BX and BECME D&D, that was no bonus or penalty. And 6 to 8 was a -1, and 13 to 15 was a +1. So if you look at that range and how likely you are to get that, you're very likely to only ever have like +1s and -1s. You might occasionally have a -2 or a +2. It'd be extremely rare, though, to get a -3 or a +3. Okay, and I think you can kind of see this on that chart. So what that means is that rolling your ability scores in order wasn't actually that bad. It's just that your ability scores weren't meant to be anything more than minor tweaks rather than huge bonuses or penalties. And if we go to the modern 4d6 drop the lowest system, that kind of skews your average from 10 and 11 to more like 12 and 13. So you're more likely to have, +1s and +2s. All right. So next, let's look at damage dice and hit dice. And this is damage dice for ordinary weapons. I'm going to get to area effect mass damage spells in a sec. So let's look at particularly at like what happens when you get like a die +1 or +2 or something like that. So the damage dice and hit dice range, it runs typically from D4s to D12s. What's interesting is that when you have a bonus, that's actually a lot bigger than you may think. Because let's say you have D6 +1. Now, how does that change things? A lot of people under the misconception that a D6 +1 is in between a D6 and a D8. But that's not exactly true. D6 obviously gives you a range of 1 to 6, but a D6 +1 gives you a range of 2 to 7, and a D8 obviously gives you a range of 1 to 8. So notice that a D6 +1 gives you a range that falls exactly inside of 1 to 8. So d6 plus 1 is actually approximately comparable to a 1d8, not worse. However, it omits the extremes 1 and 8. So plus 1 is different but roughly comparable to going up by 1 die. In fact, what this means is that your damage bonus is huge. A damage bonus essentially bumps your weapon's damage on par to 1 die higher for every bonus. So that means that, let's say you have a dagger in your hand, but you're really strong and you have a +4 to damage using it. That's bumping the dagger to almost equivalent to a d12. All right, so what about 2d4s? Because, it seems like on every weapon chart, you have like your d4, d6, d8, d10, and then you have like that one weird weapon that does a 2d4. What's up with that? Like, how does that factor compared to other types of weapons? Is that on par with the d8? Actually, it's slightly better, for the simple reason you cannot roll a 1. But you also have a bell curve, well, an angle curve, right? So 5 has a 25% chance, right? As you can see from the table here on any dice for 2d4. Whereas 2 and 8s each have a 6.25% chance. So this is great for something like a crossbow, where you figure it will do more consistent damage because it's mechanical, and you probably won't do just 1 point of damage with it. So I think 2d4s can be really well used if well placed. They can kind of give you like a little bit of a niche between d8 and d10. In fact, if you want something that's in between d8 and d10, you're better off doing a 2d4 than doing a d8 plus 1, if you see what I mean. All right, so now, as promised, let's look at area effect mass damage spells. So I'm talking about things like fireballs here. Now, in old school D&D, fireball did level d6. In AD&D 2nd edition, at least, maybe true of 1st edition as well, they had a 10d6 cap. But in BECMI, they have a 20d6 cap, which is pretty insane. So let's take a look at what you get when you have lots of dice. So let's look at 10d6 as an example. So I'm putting the graph up here from any dice. If you look at the graph, you'll notice that 35 is dead center, and it's tapered way down, even at 25 and 45. So we can immediately see that 30 to 40 is highly likely. Let's look at most of the graph. Let's look at the at most chart. We can see that there's less than a 3% chance of rolling below 25. Okay, and there's only about a 16% chance of getting less than 30. Wow. On the least graph, which I'm showing now, you can see that the same is true for less than 3% for over 45 and 16% for above 40. All right? So what this means is that there is over a 2/3 chance of getting between a 30 and 40, and over a 96% chance of getting 25 to 45. So if you're hoping that a 10d6 fireball won't do a lot of damage, it will. All right? Let's suppose we roll a bit low, and it's a 30. Now, remember, dead average is a 35. It could have been a 40, right? But let's just look at it as a 30. If you make your saving throw, you'll take half damage, which will take you to 15. But if you fail, you're going to take a full 30 points of damage. In old school D&D, that could easily kill a party magic user because you only get d4 hit points per level, and at 10th level, you're going to have an average of about 25 points. All right, now let's take a look at advantage and disadvantage. Now, these were introduced in 5e, but they're kind of all the rage in the OSR games these days, the new ones. They were not in old school D&D, but they are in kind of old school-ish games that are sort of have the spirit of old school D&D. Advantage means that you roll 2 dice and take the best. Disadvantage means you roll 2 dice and take the worst. But how does that actually change your probability? Let's go back to the D10 for just a second, even though it's often D20s we're talking about in real life, just because the math is so much easier. For disadvantage, we look back at the 2D10 table, but this time looking at the worst of 2. So let's say you need a 6 or higher, so that's a 50% chance on a normal D10. Now you need both dice to be 6 or higher if it's disadvantage. So that would mean that you have a 25% chance. 50% times 50% is 25%. Okay? 1/2 times 1/2 is 1/4. Because we multiply in probability. All right? So that is a minus 25%. For advantage, it turns out to be 75%. Because it's the chance that both numbers are not less than 6, and that chance that both are under 6 works just like disadvantage probability, but kind of in inverse. So you take the disadvantage, which is 25%, as I've already said, you subtract that from 100%, and the chance of getting it when it's advantage is 75%. So advantage is a plus 25%. If it's 50% otherwise, okay, for a normal roll. But does that change when you need a really high number or when the number is really low? It turns out, yes, it changes a lot. So let's say you need exactly a 10 on a D10. On a normal D10, that's a 10% chance, of course. On disadvantage, though, that goes down to a 1%. Wait, what? Yeah, because 10% of 10% is 1%, remember? You multiply. So you have to get both 10s. And there's only one combination out of 100 that does that, and that's 1%. For advantage, it turns out to be 19%. So I understand this is a little tricky, but you have to count how many combinations of 2d10 have at least one 10 in them. 10 and 10 obviously has 2 10s, which fits the need. So that's 1 out of 100, but there's also 9 others that the first die could be if the second die is 10, and 9 additional ones if the first die is 10 and the other die is something else, right? So 1 plus 9 plus 9 equals 19. So here, disadvantage is a minus 9 and advantage is a plus 9. Also notice that disadvantage in this situation knocks you down from 10%, which, as I've said, is well within my threshold of what is a reasonable roll to make. Because I put 5% as sort of my threshold, and knocks it down to 1%, which seems like an unreasonable roll for anyone to make. So if you have disadvantage and you need a natural 10, you basically can't do it, more or less. Okay? So is this also true of D20, which is what you're actually rolling in many cases? Absolutely. It works just the same way, only the math is a little bit harder. So if it's 11 plus, that's 50% again, so it's exactly the same as before with the 6 on a D10. 75% chance for advantage, 25% chance for disadvantage, right? But what about if you need a nat 20? Your chances drop from 5% on a normal roll to 1 in 400 because both rolls have to be 20. So that's a 1/4 of 1% on disadvantage. And on advantage, your chance turns out to be 39 out of 100. Just trust me on this. But that's approximately 10%. Okay? So advantage helps you at that extreme, but it's only plus or minus 5% approximately, rather than plus or minus 25% middling. You see? So, and I find this discouraging because advantage and disadvantage are so nifty. Everybody loves it. Like, that's why the OSRs are using them, because it's so easy compared to like these old charts. We had to look up what the penalties are, what the bonuses are. Is okay, you have a -2 to hit them because they have a quarter cover, but you have a +1 to hit because you're in short range, and you have like an additional +2 because you're flanking them or whatever. You have to figure all that out. You just say advantage, or disadvantage, or normal, and go. And the game keeps flowing. But at closer examination, as nifty as it is, I really want to include advantage and disadvantage in how I run things. But on a D20, it really tapers off. So, what does all this mean for our hobby? 1D anything is best for linear rolls in which you want every outcome to have equal weight. These are great for things like skill checks to hits, saving throws, and any other roll where you want to see if the character is capable of doing something. That's why systems like the D20 system or the D% system are so popular. I realize that D% involves 2 dice, but it's not adding them. Okay, so that's not a curve, right? It's the tens place and the ones place. Also, some OSR games are now using a D6 system for things like ability scores and skills, which is still linear. The more dice you have, the steeper the curve gets. 2d4 is fine for damage, for instance, because the damage is more uniform. So it's great for things like crossbow bolts, as I said. Lots of dice gives you a really high curve. So fireballs, for instance, are going to do a huge ton of damage, period. They won't do just a little bit of damage. There's pros and cons to this. The magic user who has waited patiently for 4 level ups to get thermonuclear attacks will really enjoy blowing people up. However, that same magic user may be very vulnerable dealing with another magic user of her same level. Okay? 3D anything is going to give you a nice classic bell curve, right? So the 3d6 is great for ability scores for ordinary people because you get this nice spread of most people being average, but some folks being a little bit above or below, and occasionally real prodigies or real failures at a particular vector of what you're good at. The 4d6 drop the lowest is great for making heroes because it's going to skew all that up by a little bit, so you're going to have fewer penalties and higher bonuses. Advantage and disadvantage are nifty, but have really unexpected results at the extreme ends. And if you want something that's easy to remember, use it. But if you want a linear bonus that's the same all the time, use the standard bonuses and penalties. Another option I thought of is, instead of the rolling twice thing for advantage or disadvantage, you might just set it at a particular bonus/penalty, like +5 or -5. That's going to consistently give you that plus 25%, or whatever. So there you have basically some of my thoughts about dice mechanics and how they actually work. Interesting food for thought. My number one takeaway is this. If you're designing your own game, or you're just homebrewing something for an existing game, be sure not to create situations that are impossible. Either that are impossible to do, or impossible to fail at. This can happen really easily, as we've seen. Remember my example of 2d10, where a nat 20 is a 1%, not a 5% the way it is on a d20. As a rule of thumb, I'd make sure that nothing ever gets worse than 5% or better than 95%. If it does, just say you either can or can't do it. But better yet, don't have situations like that in your dice mechanics, because you have these hidden impossible things or impossible to fail things. So, let me know in the comments what you think. As always, be polite. And happy dreaming, everybody.